Hello everyone. I hope everyone is fine. Today we are going to start with a new chapter, chapter number 5 Euclid geometry, as we have completed chapter number 4 linear equation in two variables. So let's start with the chapter. First of all, the chapter name starts with a word which is written here, Euclid. What is this Euclid? Euclid was a great mathematician. He was from Greece, so we call it Greek mathematician. And what he has done, he has assumed certain properties. He has assumed certain properties, and these properties no are obvious universal truth. What I am talking about, these properties are obvious universal truth. It means this you know already, means most of the properties you know already, and these properties never require any proof. Okay, there is no need to prove these properties because these properties are universal truth. That's why he was talking about at that time regarding axioms and postulates. So what are these axioms and postulates which you are going to study? These are the properties which he has studied. Okay, the properties which we are talking about. For example, properties which never require any proof and which are universal truths. So what are these? What are these universal truths? Okay, and these universal truth he has explained via axioms and postulates. Now what is axiom and what is postulate? See this, you can write it down. Even axioms, you can write the axioms, then you can write this, and you can write on the first page of your chapter postulates, then you can write this. Okay, basically we are going to elaborate it later, but right now you can write this. These are the assumptions, or you can say these are those properties which are common notion. What do you mean by this common notion? It is written here, or these are used throughout mathematics. Means any chapter, in any chapter of the mathematics or anywhere in the field of mathematics, these notions can be, means these axioms will be used. And this is not specifically linked to geometry. See, the chapter name is Euclid geometry, but these axioms were not specifically linked to geometry, and these axioms can be used anywhere in mathematics. Okay, you will get to know what are these axioms. I have not told you regarding that, and I am just giving you the overview right now. Now postulates. What are postulates? These assumptions are specific to geometry. First of all, you should know the difference between these two, why the two different terms have been used by Euclid. Axioms were used, axiom term was used because these properties which we are going to discuss in axioms, so there are some properties, 7 properties. Those 7 properties were not only specifically linked to geometry, though they can be used anywhere in mathematics. Means you can use these properties in any of the chapter. Fine. So that's why a separate name has been given to this axiom. And postulates, postulates means only properties linked to geometry. Okay, it can't be used in any other chapter. It will be only related to the means chapter related to the geometry. Fine. So these were the two main difference between axiom and postulates. After this, let us start with axioms. What you need to write in your notebook, write the chapter name, the date, and everything. After that, just start directly with axioms and postulates and write these two. Okay, pause the video and write it down. After this, you can write one of the property, means one of this line to explain what is this property all about. These properties don't require any proof, and because these are universal truth. Okay, after this we'll start with the heading axioms. What are these axioms? Let us write. First, today we are going to study these axioms and postulates, then we'll start with the exercise. Okay, because these axioms will be used in the proving of the questions which is given in exercise 5.1. First axiom is things which are equal to the same thing are equal to one another. Means this is very easy. Things which are equal to the same thing are equal to one another. What do you mean by this? Suppose there is Mr. A, Mr. B, and Mr. C. I am saying that weight of Mr. A is equals to weight of Mr. C. Okay, weight of A is equals to weight of C, and I am saying weight of B is equals to weight of B is also equals to weight of C. Can we say that the weight of A and B will be equal to each other? See, these are the two things which are equal to the same thing. See this. These are the two things, weight of A and weight of B. Weight of A is also equal to weight of C and weight of B is also equal to weight of C. Now let us take the values. If Mr. C weighs 50 kg, if Mr. C weighs 50 kg, then what will be the weight of Mr. A? Because Mr. A weight is equal to weight of Mr. C. If Mr. C weight 50 kg, then here the weight of Mr. A will be 50 kg. And if weight of Mr. C is 50 kg, then weight of Mr. B will also be 50 kg. Then can we say that weight of Mr. A is also equal to weight of Mr. B? It is very common and means a common sense we have to use, or that's why we can say that these are universal truth and it can be applied anywhere. Clear, no? See, I have not given you an example of geometry. Here I have given you a simple example of mathematics, okay, where we have applied this axiom. So that's why it is called here that axioms are not only specific to geometry, it can be used anywhere throughout mathematics. Okay, I hope this is clear. So things which are equal to the same things, here things which are equal to the same thing, and these will be equals to one another. Okay, fine. The second, if equals are added to equals, see, you have to write these all the axioms and side by side just try to understand the example. No need to write the examples. This is just for your understanding, these examples. Okay, if equals are added to equals, then the wholes are equal. Then the wholes are equal. What is this? If you are adding equal things to the already equal things, for example, let me say 50 is equals to 50. Very easy example I am taking. Only on numbers. Only I am taking numbers, no statements. Okay, 50 is equals to 50. These are equal things because here it is written equals. We have to take equals. Okay, I have taken equals. Now if equals are added to equals, okay, we have to add equal things to these equals. So I am adding 30, 30 both sides. And the result will also be equal. So maybe you are thinking, sir, this is a very common thing. So that's why the axioms are only truth. There is no need to prove them. Okay, just by a little example you have understood. So this is only the common sense that we have to use in this. So if equals are added to equals, the wholes are equal. So these were the equals and equals are added and the whole which we get are also equal to each other. Obviously they will be equal to each other. Then third, if equals are subtracted if equals are subtracted from equals, the remainders are equal. So if equals are subtracted from equals, the remainders are equal. So this is same like this. These are the equal things. Okay, and equals are subtracted. So I am subtracting 30 from both sides because we have to subtract the equal things from both sides, and they should also be equal. So the remainders in both the sides are equal to each other. So if you are subtracting equal things from equal things, simply the remainders will be equal. So equals are subtracted from equal. So this is done. Then fourth point, things which coincide with one another. Things which coincide with one another are equal to one another. Things which coincide with one another are equal to one another. How? Coincide, with one line I have drawn here, simply suppose this. Okay, let us name it line AB. One more line I am making. Okay, just wait. So I have made the another line, naming it CD. So the black line name is AB, and this blue line name is CD. Okay, so what do you mean by this? See, they are starting from the same point, this, and they're ending at the same point, and they lie on each other. So it means they coincide. If each and every point of one line is on another line, then it means the line coincides. If anything coincides like this, see here the example is not appropriate this because no, the most appropriate example will be like this. If instead of this line I'll make, just wait, uh, suppose here we have this line and I am making one more line on this, just starting from this point. See, let us go a little near. Starting from this point, the another line starts and it's end at the same point. See, the black line is just over the red line and the red line is hidden under this. It means both the lines lie on the same plane and they are on at the same point and all the points are intersecting. This point means each and every point is on each other of both the lines. If two lines coincide like this, it means both the lines are equal to each other. Very simple. So in the same way it is written here, things which coincide with one another are equal to one another. Okay. Then fifth point, the whole is greater than the part. This is very common. The whole is greater than the part. Okay, so you can take the same example in the same manner. A line AB, okay, in between one more line CD. So we can say that this line CD is the part of line AB. Yes, no, because AB is the full line starting from A to D, and CD is just a part of this full line AB. This is just starting from here on this line and is ending at on this point. So CD is just a part of the whole line. That's why we can say that the whole is always greater than its part. Very simple. I know. So anything you can use this on anything. It is just universal. So whole is always greater than the part of it. Okay. Sixth, things which are double of the same things are equal to one another. So things which are double of the same thing. Suppose these are two things, uh, 50 and 50. Things which are double of the same things. Suppose these are the same things. 50 and 50 are equal to each other. These are same things, and if we will double them, then these will also be equal to each other. Very simple. In the same way, the next axiom is things which are halves of the same thing. See, these are same things. If we will calculate the half of this and half of this, then we'll get 25, as these will get cancelled, and both the side will be 25. So here also these are equal. So it is very simple. If the things are equal and if we will do the double of those things, then it will be equal to each other. And if the things are equal, if you do half of those things, you will get the equal answers again. So all the axioms are over. 6 I have explained you. Now 7 also I have explained you. 7th is things which are half of the same thing. Things which are halves. This is the plural form of half. Plural. This is plural of half. Okay, things which are halves of the same things are equal to one another. So these are all the 7 axioms which you need to write in your notebook. And after this, let us talk about postulates. Okay, so moving on to, you also have to make a note on this axioms. Just write in your notebook all the axioms, and after that start with the postulates. Put the heading postulates. Let us see what are these postulates. So number one postulate is, postulate number one, a straight line a straight line may be drawn from any point to any other point. Means this is a totally common sense. A straight line may be drawn from one point, from any one point. We can write here any one point to any other point. A straight line may be drawn from any one point to any other point. Yeah, you can draw a straight line from any of the point here, and you can stretch it to any other point. So there is no fixed point from where you have to start. There is no need to think even. You can start drawing a line from a point to the other point. It is simple as that. Okay. Then second postulate. So postulate number two, a terminated line a terminated line can be produced indefinitely. Can be produced indefinitely. Now, what do you mean by this? First of all, you should know the meaning of terminated line. Terminated line means a line segment. Euclid called line segment as terminated line, so do not get confused. Terminated line means a line segment, so I am making here line segment. So this is a line segment which has two endpoints, this the starting and the end points. So these are the two endpoints of a line segment. So line segment can be produced indefinitely. Yeah, you can produce a line segment. Yeah, you can draw here, start making lines. For example, this is not a straight line. You can make a straight line in your notebook with the help of scale. Okay, we can produce the lines from both the sides indefinitely. Okay, clear? No? Yeah. If a line segment is drawn, if a terminated line is drawn, it doesn't mean that we can't produce it. We can produce a terminated line even. Okay, this is our choice. We can draw it. Fine. So that's why these things we are using in our construction means you will get to know when we'll move to chapter number 6, 7 and further chapters 8 and 9. Okay, how these things will be used. So I guess you are able to understand the things because it is clearly written a terminated line can be produced indefinitely. Yeah, we can produce a terminated line from both the sides. No issue. Third, a circle can be drawn with any center and any radius. With any center means when you are making a circle, then you can start a circle with any of the center. Okay, and with any radius of your choice. Right here, and any radius. Obviously, suppose I want to draw a circle from this center, I can draw. If I want to draw a circle from this center, I can draw. If I want to draw a circle with this center, I can draw a circle. Okay, something like this. And if I want to draw a big circle here with a big radius, so that also I can draw like this. Fine, no? With something like this. I hope this is clear. We can make a circle with any radius. This is a smaller radius. Okay, and this is a bigger radius. You know, here the radius is smaller, here the radius will be bigger than this. So this is our choice. With this we can do. So this is also a kind of common sense which he was talking about. Means these things no never need proving. This we can use in our mathematics anytime. So he was talking about these all things which is always with us. We can use this anytime to prove other things. Fourth, all right angles means you will say, sir, what is this? All right angles. what I am going to write, see this, all right angles are equal to one another. I will say, sir, obviously, sir, they will be equal because all right angles means 90 degree. So if all the angles are 90 degree, they will be equal always. Okay, so all right angles are equal to one another. So this is also done. Now the last postulate, which is a lengthy postulate, and you have to learn that. Okay, I'll explain to you that what they are talking about in easy language. First of all, we should write the way he has explained or he has written. Means Euclid. The fifth postulate, write it down. If a straight line, the straight line falling on two straight lines, falling on two straight lines, falling on two straight lines makes the interior angles on the same side of it taken together. Might be you will not be able to understand right now. I'll give you the example to make you understand this. First of all, just write it down in the same manner. If a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the then the two straight lines if produced indefinitely this is just looking big, it is not that much difficult, this is easy. If produced indefinitely meet on that side on which the sum of angles is less than two right angles. So this is over here. Pause the video and write it down by the time I am making the figure for you. So just see this. Let us make the diagram. Was it saying if a straight line falling on two straight lines? Okay, I am making two straight lines. First of all, okay, and one more straight line I am making. Okay, so these are the two straight lines. Why I have made like this? What is the reason that I'll tell you why I have made like this? Why not two parallel lines I have made? Because it is written here. Okay, if a straight line falling on two straight lines, see two straight lines we have made. So this is done, two straight lines. Now a straight line should fall on these two straight lines. Okay, let me draw So this is a straight line which is falling on two straight lines. Okay, so let this line be L, let this line be M, and let this line be N. So line N is falling on two straight lines which are L and M. So, okay, first line is all clear. Now listen it very carefully. Makes interior angles on the same side of it taken together less than two right angles. Okay, just be very straight to this line, that makes the interior angles, which interior angles they are talking about, and on the same side of it. Okay, again, a straight line falling on two straight lines, then the interior angles, these two interior angles falling on the same side of that line. So this is a line and we have to look at the same side. If we are looking at this side or we are looking at this side, there are two sides. So let me explain you this. I am taking two different examples for this. This side I am taking these angles, because if they are saying that makes the interior angles on the same side of that side, so this is a line and we have to go to the same side. So this is one side and this is the another side of the interior angles. We have four interior angles. See this. Okay, interior means interior to this line. See, these are two lines. Okay, and in between we have four angles, 1, 2, 3 and 4, and these all four angles are interior angles. Okay, now they are saying the angle should be on the same side of the line. Okay, these are the two angles on left side of the line and these are the two angles on right side of the line. So which angle they are talking about, these two angles or these two angles? Let us read further. On the same side of it taken together, if we will take both the angles together, then it is less than two right angles. What do you mean by two right angles? Two right angles means 180 degree. This means less than 180 degree. What do you mean by this? If we will take the two angles together, then they will make the sum of less than 180 degree. So can you suggest me, are these angles making less than 180 degree sum or these angles are making less than 180 degree sum? Obviously these angles will not make, these are big angles and they will make more than 180 degree, and these small angles will make less than 180 degree. So here Euclid is talking about this figure, not this figure. So this is of no use. Okay, why I am saying that these will make more than 180 degree? Because see this, if you can see clearly that this angle is an obtuse angle more than 190 degree. If this would be like this, then this is right angle. If it is something like this, then it is obtuse angle, which is more than 90 degree. And here also, this angle is not straight like 90 and it is more than 90. That's why it is also obtuse. Obtuse means more than 90. Let it be 95. More than 90, let it be 110. If you will add them, you will get obviously more than 180 degree sum. Okay. If two angles are 90 degree, then you will get 180. If angles are less than 90 degree, then you will get less than 180 degree sum. Okay, if the angles are more than 90 degrees, suppose 95 plus 95, then you will get more than 180 degree sum. Okay, and what they are talking about here, the angle should make less than 180 degree sum, and this is possible only here because these two angles, this angle and this angle, both are acute angles which are less than 90 degree. That's why they will make less than 180 degree sum. Okay, then the two straight lines, if produced indefinitely, okay, if these two straight lines which we have written here, these two straight lines, if we will produce indefinitely, here also just keep on producing it, here also keep on producing it, here also keep on producing it, here also keep on producing it, then you will be able to see that these two lines will meet at one side. This side they will not meet, but this side obviously they will meet. And this is not very common. I have told you that it is written very lengthy, in a very lengthy way, but this is very common and easy to understand. Okay, so they will meet obviously if these are not parallel lines. This we have already learned. If these two are parallel lines, they will not meet, they will never meet each other. Okay, if these two lines are not parallel, then if you will produce them further, then they will meet at one point. Okay, now what is written further? Then the two straight lines, if produced indefinitely, meet on that side. From which side they will meet? Left side or right side? On that side on which the sum of angles is less than two right angles. Again, where the sum is less than 180°, that side they will meet. So here the sum is less than 180°, that's why they will meet this side. And here the sum is more than 180°, that's why they will not meet this side. So here the example is all over. I hope this is clear to you. Again, you can see if a straight line falling on two straight lines, a straight line n falling on two straight lines, okay, makes interior angle, and these interior angle we are talking about this side and this side, there is these two. If you will take them together, they will make less than two right angles, some less than 180°. Then the two straight lines, if we will produce indefinitely, then they will meet at one point, and they will meet from that side in which the angles are less than 180°. Okay, so here we are over with all the postulates and axioms. I hope the things are clear. If the meanings are clear to you, just go through the video one or two times. You will be able to know the meanings of each and every axiom and postulate. Then we'll start with our exercise in the next lecture. So this is done. So your homework for today is read and write all axioms and postulates, and even read and learn. Even it should be there in your mind, as we have to do this, use this in the further exercises. Okay, bye, take care.